So if you have a few DEMs, you can start to do some raster analysis to get contour, slope, and aspects. So I have downloaded a few DEMs, so let's get them in first. So right click and add folder connection, and for me it's gonna be DEM data. So inside my DEM data I have a few tiles, so I will only get the 2016 tiles, so these 4 tiles. So I'll drag and drop them, and there I have 4 image tiles. My aim is to create some analysis for these 2 lakes, so I'll try to do that. Now if I want to work with 4 of them, I have to work with this horrible seams, and I'll also have to do everything 4 times. I don't want to do that. So instead what I'll do is I'll create a mosaic. So I'll go to analysis, go to tools, and then I'll search for mosaic. And for me it's going to be mosaic to new raster. So I'll click on that. So it asks for input rasters. So I will just show it the 4 tiles that I have imported. And it also asks for an output location. So let's select that into the mosaic folder that I have created before. It asks for the raster dataset name with an extension. So for us it's going to be the TIFF. So we'll use mosaic raster.tiff, and let's make it 32-bit signed. Cell size is an important parameter. To get that, you'll right click and go for properties, and then go to source right here. And here you have cell size X and cell size Y. They're square, so it's gonna be 1. So let's make it 1. And because this is a DEM file, we only have 1 band. So let's make that 1 as well. And now I'll hit run. So now I have a clean mosaic raster. I can delete all these, but I want to keep this if I in case need them later. So I'll create a new layer group and name them imported DEM and hide all of those because I don't need them right now. This is what I need. So now I want to create a contour on this DEM. So let's go for tools. And now let's search for contour. So here I have the contour. It says creates a feature class of contours from a raster surface, which is gonna be this. So let's click on that. Input raster gonna be mosaic raster.tiff. Output feature class is gonna be this. That's created by default, and this is the contour interval. Usually we do 1 feet, but because this is such a large site, I'll make it 5 instead of 1. And now we can just hit run. So there we have a contour map of 5-foot contour interval. So that's really nice. And I can also change the contour colors to white so that it pops a little more. And also what I can do is I can see the contour numbers and their elevations. I can right click and go to attribute table to see where my contours are. So you can see the field contour have the contour data. So let's use that for our label. So right click on this layer and go for label. It takes a while because it's a very large data set. Now we can go for labeling over here, and field can be contour. So there it will change into the contour intervals of proper elevation. And I can also try to make this into white to match the property of the layer. And now I can turn off my mosaic raster, and you can see we have a nice contour map over our actual site. This is pretty neat. Now let's talk a little about slope analysis. When we create a slope analysis map from a DEM, we are essentially translating raw elevation data into information that explains how the land behaves. Slope determines how water moves, how people move, and how vegetation establishes itself. Here you can see a small table. This tells you different percentages of slope and what they do. So it affects runoff velocity, erosion potential, accessibility, maintenance requirements, construction feasibility, and even the microclimate that forms across a site. Understanding the slope is one of the most fundamental steps in landscape analysis. This classification table helps us interpret the landscape in a way that is meaningful for design. For example, slope between 0 and 5 are ideal for accessible routes. The slope increases into 8 to 10% and it makes walking more strenuous. Runoff begins to intensify. Once we cross 15%, erosion risks increase and we start thinking about terracing, retaining structures, or specialized ground covers. Beyond 33%, we are dealing with highly unstable terrain that may require engineering intervention. So we will learn how to assign this in ArcGIS and how to learn a slope analysis. So here we have the DMs from before. Because slope analysis is actually a pretty daunting task, we will create a smaller area where we will run our slope analysis. To do so, we will turn off everything that we don't need. So we just need this tile. And I'll also don't use the whole of it. I'll create a small clipping boundary so that we can uh, we can run the slope analysis in a smaller area. So I'll speed this part up. So there we have our clipping boundary. And now let's try to run the slope analysis. To do so, we will go inside analysis, we'll go inside tools, and then we'll type in slope. So here we have slope 3D analyst tool. We will select that. Our input raster is gonna be clip USGS 1 meter. And instead of degree, we'll make it into percent rise because we know how different percentages affect the landform. And then we'll just hit run. So there we have a nice slope analysis going on. You can see it's showing different colors in different classification. Now we will reclassify this. To do so, we are gonna right click on it and then go to symbology. And now let's change all these percentages. So we have that table. So I'll just change the upper values by that table. And now we can color code all this. So let's select all this by pressing Shift and now change that. There is a nice color scheme for slopes itself. So I'll click on show names and then I'll try to find that. So here we have slope. I'll select that. And now you can see it kind of shows you exactly where things are uncontrollable, exactly where things work, where they don't. And we can also start to label this into the symbols that we can understand. I can name it by percentages, and I can also name it by their interpretation. I'll name them by interpretation. So there we have our slope analysis. And if we print it on layout, we can see all those labels in their own color scheme. So that's how you create a slope analysis. Now let's talk a little about aspect. So aspect analysis tells us the direction that each slope on a site faces, north, south, east, west, and everything in between. It shows a compass direction just like this, and then color codes different directions into these colors. While slope analysis explains how steep the land is, aspect explains which way that steepness is oriented. This is important because the orientation of a slope directly influences sun exposure, shade patterns, soil moisture, vegetation health, microclimates, snow and ice melt, and even human comfort. South-facing slopes in northern hemisphere receives the most sunlight, creating warmer, drier conditions that support drought-tolerant or sun-loving plants. North-facing slopes are cooler and moister, which can be ideal for shade-adapted species or areas where you want to reduce heat gain. East-facing slopes get gentle morning suns, while west-facing slope receives hotter afternoon sun, something critical for outdoor comfort and planting design. So now we'll learn how to create all this in ArcGIS. To do so, we are going to use that same clipped boundary that we have created before, this one. And now, instead of slope, we'll go to Tool and search for Aspect. So here we have Aspect 3D Analyst tool. We'll click on that. Our input raster is going to be the same. Clip USGS 1 meter. And we won't change anything. We'll just hit run. So here we have our aspect analysis. It's already done for us, and you can see it comes with a standardized symbology already. So it comes with all those standard colors that I showed earlier on. We can also create a specific histogram out of this to understand which specific aspect dominates the whole clip boundary. So right click and create chart histogram, and here we are gonna use just the band 1, and you can start to see different ranges between -1 to 360 and everything in between. So here we can try to understand where's the median at. You can see the median is somewhere in the middle, 168 point something. So that means it's a pretty uniform land, sloping everywhere. So that's actually useful to understand what type of planting or what type of design will dominate the landform. So that's how you do aspect analysis.